Hello, what's up everybody? Today I'm going to be um, doing scene management, and that's the second part of the games and visualizations thing I'm doing right now. Let me check something real quick. Okay, so so this is the first what are scenes thing, but first before I go and show you guys that, I'm going to show you something on my channel that I put. So each live stream or each live stream or video that I do for Advanced JS, the games of visualizations, I just put it um, into a playlist so you guys can click play all, and it shows all the like videos that are there. And then there's upcoming live streams, which is buttons. That is scheduled for tomorrow, and scene management is what we're doing right now. As you can see, I have um, my um, profile picture as different because I had it that way because of the contest winner thing that I did, which I did know was going to be a bummer, but it was. So I just wanted to show you guys that, and also I'm going to go on to. Well, actually, I'm just going to um, copy this link into the chat, and then so here's the link in chat. That's for the what are scenes if you want to follow along with me. So there's just two documents, and then there's a challenge, and there's three more documents, and then there's buttons. So what are scenes? Many games and visualizations have what we call scenes, and they need some way of managing those scenes. What do I mean by scenes? Take an example for Balloon Popper 2. It has 4 scenes. So I'm gonna click on this link. It's probably a game. Yep, it is. So it's Balloon Popper 2. Click to play. Oh jeez, that was a very loud, screechy noise. I'm going to take that. So there's a how to play screen. There's one pin, two laser. So all I have to do is drag my cursor, and it pops balloons. Make it like a you probably get the gist of it. Now game over. And then hit enter to play again, and use the arrow keys to fly your balloon popping pin around the screen. Let's do pin. So this is a little bit more like up and down is that. So that's how you do that game. We're not going to continue with that, but there's a start scene, which is the click to play, a how to play scene, a playing scene, which we did, and then a game over scene, and then most games have those scenes. In fact, each scene is a distinct state of the program that displays different information, and there is a way for the user to get from one scene to the next. Maybe it's a simple mouse click or key press, or maybe it's selecting a scene from the menu. Once you realize that you need something like scenes for your program, you'll have to decide how to program them. Like many things in programming, there are many ways to do that, but we'll hopefully give you a few ideas. And then there's simple scene changes. So they give you code, and look at this. There's code. So simple scene changes. Let's say we want to tell the story of Winston as an illustrated storybook with the user clicking to read the next part of the story. We'll start off with a main scene, just like it has in as a title. Now we want it so the user can click to see the first part of the story, Winston's epic birth. To do that, we can define a mouse click function that can be called whenever the user's mouse clicks. Whenever the user clicks the mouse, we can input the code or draw our second scene there, and note that we have to call background before dropping a second scene. Otherwise, we'll see both scenes on top of each other. And then it shows another thing. And then try it out on the program below. Click to see the scene change, and little Winston get born. So that little Winston's born, and boom. Okay, so now you want to try editing the code for a second scene, like changing the text or placement. Do you notice that every time you want to see the results of your edited code, you have to click to see the second scene? So let's just move this around. So, oh, look at that. So yeah, and then personally I find that annoying, as it means to take so long to edit scene 2 to be exactly how I like it. Imagine if we had 10 scenes and wanted to edit scene 10, we'd have to click 10 times for each edit. Yeesh. So let's solve that problem. Yes, you can. Yes, you and I can survive with annoyingness, but we all want to be more productive programmers, and won't we be more productive if we can see results of your coding in real time? This in case, an easy thing to do is to wrap all the scene 2 code inside the function. Call that function from mouse clicked, and then call that function when we're debugging. Here's what I mean. So they called var draw scene 2, and then they did that, and then draw scene 2, they called it out. As long as we made scene 2 into a function, we may as well make scene 1 into a function as well, just wrapping up all that code up and calling it. And then they show us that, and then now try out the program below. This time, if you want to make edits to a scene, you could simply uncomment the draw scene 2 call and see your edits rendered immediately. So you get that. So now well, we have to code out the draw scene. So we got // so I mean, you can just do this in // now you can just see your edits being changed with a click. See, it's just going up and down. So there we go. Great. So we have a main scene, and second scene. What if we want to display the third scene, or go back to the first scene once we clicked on the third? We need to change the logic of inside mouse click so that it conditionally chooses which of the scenes to show instead of always calling scene 2. That means that we need an if statement to check that to check some sort of condition. Let's think about this in terms of pseudocode first, and then it shows if the current. So when the user clicks the mouse, if the current scene is scene 1, go to scene 2. If the current scene is scene 2, go to scene 3. If it's on 3, go to 1. It looks like we need to keep track of the current scene, and it may make the most sense to store it as a number. Let's declare a global variable current scene and check it inside mouse clicked. So they do that, and then the conditions look like our pseudocode, but there's one problem. We'll never actually set current scene to the value. So these conditions will never be true. We could set it inside the if conditions, but it's probably better to set inside the scene drawing functions themselves so that the variable is set correctly no matter where we call scene drawing functions from. So we have all that. So drama scene 1, the current scene 1, current scene 2, current scene 3. We put it all together in the program below. Click through it and see how it cycles around the beginning of the story. Try adding a scene for Winston meeting Oh No's, Winston meeting Winstonia, and moving on to Winston, and spin it off. Challenge Storyteller. So make the story respond to mouse clicks. So there's 3 things that I need to do. So you're going to tell a story of leafers who start as a seed and grow to leafers ultimate form using scenes. We provide you with a draw scene 1, a scene drawing function for the first scene where leafers is just a seed, and draw scene 5, a scene drawing function for the 5th and last scene where the leafers is in the ultimate form. Your task is for this step is to add logic to the mouse clicked function so that if the first scene is displayed when you click the mouse, it will display the last scene. If the last scene is displayed and you click the mouse, it will display the first scene. So there's just a bunch of code. So okay, we can go back to this. So var, draw scene, all that stuff. I think it's not gonna let us copy from the outside. Wait, it did. It did. Unmatched. That. Well, it's right here. Looks like you're missing a semicolon. Unmatched. Okay. Okay. So var draw scene 1. So the scene, okay, current scene. Draw scene 1 function. Draw scene 5. So I guess it just wants us to do the mouse click function. What? What? Draw scene 1 function. That's that. So the documentation, the processing JS's shapes and all that stuff. Okay, so mouse is pressed. Wait, is it mouse is pressed or mouse clicked? Call when the mouse is clicked. So mouse clicked. This function. What if this becomes in that? Draw scene 1 is not defined. Maybe you meant to type draw scene 5, or you're using a variable you didn't define. So I don't think a function can be inside a function, but I don't know. So I forgot about the hint code. The hint code is actually what we're supposed to type, which is if something equals that, and then else if something equals that. So there's a pink, and there's blue, and there's an orange, but there's two oranges, which is the both variables. And then the pink and blue are, I think, are just more variables or something. Oh wait, it's the calling function for them. Okay, so it's 720. We got through the first two. Okay, I'm gonna try to figure this out. Okay, so I finally figured it out. Um, okay, so now we're in step 2, and we'll go to step 3 after this. So we have to make scene 3 and scene 4. So each scene should update the scene index, current scene, and to the scene number. Draw a unique background. Display an image of leafers. Have text describing the scene. So um, there's a bunch of variables as images, and there's seeding and sapling. I'm probably going to use the seedling and sapling, and then there's a tree one, which I don't know. Is this tree? Well, that's a tree. That's the other one. That's the first, the second, the third. Well, or second, third, fourth, and fifth. So we did the first and fifth scene. Well, they did it. We just did whatever. So far, draw scene 3. 3, yes. 3 equals function, and then this should have a oh wait, draw scene 3. Okay, 3 should have the current scene, background, the image, the text. So it should have all of this. But okay, so now I know what to do. So paste it on here, but um, this seed would be seedling. So seedling. So seedling and scene 3. Okay, so that is good. Okay, now I'm gonna just put in there. Wait a minute. Nope. There. Draw. Draw scene 2 equals function just be that semicolon. Okay, so scene 2 seedling. No, it's not seedling, it's a sapling. So sapling, which is that, and then this current scene 2, yep, current scene 3. So now we need a fourth. So var whatever from scene, and then 4 equals function So now I need to paste that in. This should be a 4. That should be cherry. Right, yeah. Okay, so tree and then ultimate. So all your scene functions should draw backgrounds using unique, but at least 2 of your scenes should use the same color. Same color. Okay, so that. Wait, so this using that. So this should be a copy. Paste. So 2 of your scene functions should use the same color, which it does. One uses that. So now I need to add else if statements, but first, okay, so, um, so the text should be different. So, seed stage. Then sample. So, okay. Um, so that's for Storyteller. Like, let's check in on the color. 196. So, add logic to tell the whole story. Now we're gonna use the if, else if, else if, else if, else if, but we're gonna use it in one line, not like 3 or 4 lines, just one line of code that needs to be used. In order to do that, we'll just go down to the if statement, which we did if one if statement. Now, current scene, that. Now we just do this. Well, actually, yeah, that. Then this. We can still do that with the else statement too, so let's just do that. Oh wait, let me select that one. Then else if, wait a minute, instead of just saying else if, else if, else if, let's do just copy paste, because copying and pasting is a good thing and a bad thing. But this, it's a good thing. So scene 2, draw scene. If the current scene is 3, draw it to 2, 3. So 3, 2, 4, and then um, 3 to 4, 4 to 5, and then 5 to 1. So 1 to 2. So we did it. We made a storybook on a leafer. Sea stage and sapling, become tree. So that's good. Now let's go animate scene. So it's just. Oh wait. Winston Ladro. Oh, simple something, I don't know. So we've seen how to make multiple simple scenes, but our scenes were what we call static, and they weren't animated, nor did they have a response to the user interaction. Well, as we'll see, it requires a bit more finesse to handle fancier scenes, but hey, let's get fancy. Let's talk about animation. Um, so what if we wanted to show Winston in this rockstar phase drumming hard to the beat? We normally do that by defining the draw function to contain code that draws shapes and that move position slightly each frame. Here's an example where the position of the drumming hands is based on the current millis value. Um, the number elapsed in milliseconds. So it's just Winston on the drum. So what if we add that as our scene 4, for example? We'll add that as scene 4 to our previous example. We'll move the code into draw scene 4 function and modify our mouse click logic, and then they do it right here. Try it below, click through a few times. So story Winston, this is born, it grows up, and then yep. So no, something it worked, but only kind of. We could see Winston with his drum set, but his drums weren't moving. How sad. Um, It is hard to make music when you're frozen in time. Perhaps you've already caught into the issue. We're no longer calling the drumsticks drawing code from within draw, so it's only getting called once, not repeatedly, and thus only rendering the sticks at the moment in time at which it's first called. Perhaps you've also already guessed the solution. Define the draw function and call the draw scene for when appropriate. It shows, let's just think it through a little bit, and then um, they show that. So, okay, um, okay, let's just think through that a bit. Whenever we define a draw function in our code, it's getting called repeatedly, defaulting to 60 FPS, and whenever it's called, when the current scene has already been set to 4, then it'll call the function to draw scene 4. When it's in any other value, it won't attempt to draw anything at all, keeping whether it was already on the screen. We'll still need to do the initial scene drawing in mouse click. This logic just takes care of animating every frame after. Some of you might be thinking, why don't we just have logic that calls every scene function inside the draw? Well, you certainly could. That means that if you add the animation to the other scenes, then they would just work immediately. But assuming you don't animate your other scenes, that means that you're making the computer redraw those scenes repeatedly for no reason. Um, from a performance perspective, that's not good. If we know what we can easily save the computer unnecessary work, we should. It it will make our programs faster and users happier. Okay, alright. Now that we discussed all of that, here's a story, and it's clickable. Anime glory. You can almost hear the beats coming out of scene 4. So, story Winston. Lois is born. Winston grows up. Look at that. I'm glad that there's like an animation thing. So now that's done. Interactive scenes. Okay, so now that we know how to make sweet animated scenes, let's make sure we can handle the other sort of non-static scene. Scenes that respond to user interaction. For example, we want to draw a scene where Winston has babies after his rock star phase, of course. Um, but we also want to let the user click to give Winston more babies. Um, because we can always use a little more Winstonitos in the world, right? Here's what that scene would look like as a standalone program. The program draws a static part of a scene, then in mouse click it draws the Winston baby images, and at the click mouse location layering them on top of the whatever is already drawn. Da, 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 da. So now we have bombarded baby Winstonians. So let's go. Okay, now. So how would we integrate with our multi-scene program? Well, we'd start by just wrapping all the scene static drawing code into a scene drawing function. Draw scene 5. and adding scene switching logic to mouse clicked. There it is, all that stuff. Here's what it looks like. Willis is born, winter is up, it says babies, wait, so it goes back. But how do we integrate mouse clicks functionally? We've already defined mouse click in our code. We can't define it twice. In JavaScript, the last function definition wins. It overrides any previous definitions. That means that we need to find a good place to put that baby drawing line inside of our existing mouse click. Let's talk about a few options. There's 1, there's 2, there's 3. So 3 gets it in the current scene 5 block thing. There's 1 where it goes there, and then we can put it at the line at the top of the function. So there's those. So we could stop redrawing scene 1 at the end and tell the user to restart. In that case, sure, that worked, but that relies on the fact that our click controlled screen happens to be in the last one. What if we wanted an earlier click control scene? That solution would fail. 5. We could use different sort of interaction, like mouse dragged. Mouse drag, that's a new function. Yep, new. So that will work because dragging doesn't also cause a click event. We still need to check that current scene 5 to make sure that dragging doesn't draw babies in the other scene. Then it just shows that. Try out below, make sure you drag on the final scene. And yep, it does. Does it? Does good, but there's not like, there's like that. So there, they even made the thing that says drag to make more Winstons. So okay, so that kind of works. Although I'm a bit worried about how many babies Winston might end up with. Generally, that's not an optimal solution since it means we have to limit ourselves to designing scenes that don't respond to mouse clicks. We don't want to have that constraint. There must be a better way. What if we instead differentiate mouse clicks by location, so that a click in one location would mean changing scenes, and clicks elsewhere could be used for a in-scene interaction. You know, like a button. In fact, that's how most multi-scene programs approach this problem. We'll talk through that next. And then there's a button-controlled scene changes. There's another document thing, but we're going to do buttons like the full button lesson like tomorrow. But we're going to talk about this first. So we've gotten away so far with just having the user click anywhere at all in order to change scenes. But we've realized that there's a drawback to that approach. We can't use clicks within scenes for any sort of additional interaction. The way that many games and apps solve that is by adding specific UI elements like menus and buttons. In only navigating scenes upon interaction with a specific UI element, let's add a button to the top right to control our scenes in the program. What's a button? It's two things. The visual indicator that an area is clickable, and 2, the logic that makes that area respond to clicks. Let's start with a visual indicator. A rect with some text and wrapped in a function in case we want to call it multiple times. So it's draw button type. Yep. So now where should we call it? There's 4. As a general rule, we want to call functions only as often as actually necessary. No more than that, otherwise we're just wasting our computer's energy. And then try it for yourself. If you feel like you need it anywhere else, you can always take another call in your code. Woo, now we got a button in every scene, all the time. Check it out. So there's a next. See? Next, next, next. There's another way. You just click, wait a minute. So 1, 2, 3, 4. After we drag, whenever it clicks next, it still clicks. But, haha, you know what's hilarious? The button does nothing. I mean, the user might think it does something if they decide to click only in that area, but in fact, they could click anywhere. But it did the same thing. We need to change our mouse click logic so that we check the button location before we decide it's seen a changing time, like we did in the button challenges in Intro to JS. We need to come up with an if condition to check mouse X and mouse Y conditions. All these things must be true. Is mouse X greater than the X position? And then it just shows the other questions. We use and to check all 4 conditions are true. They show the example for it, and that's it with that check. We now have a program where the user clicks a particular area of the screen to move to that next scene. Try it out clicking the button and non-button parts. So here's me clicking non-button parts. Button, button, button. So it's drag instead of clicked. I mean, this person could have did a click, but I don't know. I mean, yeah, I'm not sure. I'm not the creator of this code. Only Pamela. I mean, wait, is it Pamela? Is that the person's name? I don't know. I think it is. So, I will be back in a minute. And yeah. Um, okay. Let me grab a drink real quick. I'll be back. Okay guys, I'm back. So, now that we have a way of knowing when a click is meant for changing scenes, we can use clicks for other interactions in our scenes as long as they're not clicking on the button. That means we can let the user add the Winston on click instead of drag, like we originally wanted. We'll just add an else to our if and move the code from mouse drag to that else. So they show the example. Note that we need to keep check for a scene, that to make sure that it only happens for that scene. But now it's easy for us to add click the interaction on any other scene to what else could you let the user add drums, facial hair, play around with the program below. So there's the next, there's next. Yes, there's a drag. There's a, oh yeah, there's a click to add. Yes. It says drag by click. And then, there we go. So that's the whole entire scene. Next lesson is buttons. And then it shows us examples. And then 3D roller coaster. So there's mini putt, 6 reasons not to be a fly, and roller coaster. Let's do, I mean we can do any of these, but check out these example programs to see how they use buttons. But we're gonna get buttons in the next stream, so I hope you guys have a awesome day, and I will see you guys there. Bye.